Hello. Am I clearly audible?
Yes, sir.
Okay, thank you all for joining here. So in this lecture, we want to continue the lecture on hypothesis testing, that is inferential statistics part 1. So in our last class, so we have discussed about that is what is inferential statistics, how it is different from the descriptive statistics, what's the use of inferential statistics, and the distribution, the proportional distribution. So different types of distribution we have discussed also, and for there is the normal distribution, the characteristics of normal distribution we have discussed. And in this lecture, we have also started the hypothesis testing part, and we have discussed also that is what is hypothesis, and then uh, what is called the null hypothesis and what's called the alternate hypothesis. And from a small scenario, how can we find out that is the null hypothesis and also the alternate hypothesis. Okay, so those things we have discussed in our last class. So G score we have discussed about the G score, how to calculate the G score, and what's the use of G score. Okay, so now on we can start from this one, that is hypothesis testing example. So for the hypothesis testing, so at first we need to state the null hypothesis. That means we have to find out what is null hypothesis. And then we have to state the alternate hypothesis. This is our next phase, next step. And third, state alpha value. Okay, that is the alpha value, or we can say the significance. So we have to define the significance level, okay, the alpha level. And then find the rejection area of our from the G table. Okay, we have to use the G table for finding out the critical point, and then the rejection point or rejection zone or rejection area, and then find the test statistics. So test statistics according to our data, what will be the value of G. Okay, so test statistics, and then based on that we have to decide that is whether it will be rejected or accepted. Okay, rejected or accepted. Okay, so now let's say one example is given here, one of the scenario, like here blood glucose level for obese patients have a mean of 100. Okay, have a mean of 100. So it is blood glucose levels of obese patients have a mean of 100 with a standard deviation of 50. So the blood glucose levels of obese patients, maybe you can say the average, the mean is 100 and standard deviation is 15. A researcher thinks that, so this is the researcher's hypothesis, that a diet a diet high in raw cornstarch will have a positive or negative effect on blood glucose levels. Okay, so here will have a positive and negative effect on blood glucose levels. So the researcher mentioned that a diet with high raw cornstarch maybe that will impact positively or negatively. okay, or we can say that positive or negative blood glucose levels. And to prove his hypothesis, what he has done, a sample of 30 patients, who have tried raw cornstarch diet have a mean glucose level of 140. Okay, so mean glucose level here is 140. There's the hypothesis that the raw cornstarch had an effect. Okay, now in this case, what we have to do, at first we have to find out the null hypothesis. Okay, we have to state the null hypothesis. And null hypothesis in this case, we can see those are numeric values. Okay, that is the mean glucose level. Mean glucose level is increased here like 140, and the mean of the existing mean here is just 100. Okay, 100, and standard deviation is given here 15. So it means that so we can say that in this hypothesis, the null hypothesis, or we can say that the common belief or existing case, here is the mu is 100. Sorry. So in existing case, the mu is 100. So here is the mu. There is mean. Okay, so mu is a mean is 100. Glucose level is 100. So this is our null hypothesis. That is H0. And it is mentioned that the researchers thought that, or his hypothesis is, it will be positive or negative. That means it will not 100, it will greater than 100, or we can say less than 100. So we can see here the mu for that case, alternate hypothesis, it is not 100. Okay, not 100. That means it can be greater than 100, or it can be less than 100. And now, so we have already defined our null hypothesis, then alternate hypothesis. Now we have to say our significance level. So here we can see that the significance level, the alpha value, we set the alpha equal 0.5. So alpha equal 0.5. So that means we can say our significance level here is 0.5. So we want just maybe we want just 95% of confidence for that. Okay, so that means the significance here is 0.5. So we want just confidence 95% confidence. Now for the third here, find the rejection area from the G table. Now from the G table, we need to find out the rejection zone. Now in this case, we can see that for our testing purpose, usually we assume that the data is normally distributed. Even though sometimes it is not normally distributed, but we assume, okay, for assumption, specifically for some kind of statistical testing, we will assume those things. We will discuss it more maybe a few slides later. But at this stage, you can assume that the data we have that is collected, those are just normally distributed. And for that case, for normal distribution in our previous day's lecture, we can see that, okay, maybe the data is normally distributed. It means that it will follow this kind of distribution. So here, the 50% we will get this part, and 50% we will get in this part. Okay, in this part. Now we can see that that is here the 0.05. That means we can say 5%, and this testing is kind of the two-tailed test. Why two-tailed test? Because we can see that it is not only greater than test, it is also less than test. That means we can see mu not equal 100. So it is two-sided clause. Okay, that means we can say it can be greater than and it can be less than. That's why it can be greater than. That means it can be in this side. It can be less than. That means it can be in this side. Okay, so that's why usually we call two-sided test. So in this case, two-sided test. So 0.05, that is a 5% error. We can say, we can maybe 5% error. We will count that because we mentioned that the significance is 0.5. So this 5% we have to divide in both sides. Okay, we have to divide in both sides. That means we can say 2.5% in left side and 2.5% in right side. So here we can see that from the 50%, if we subtract like 2.5%, then it will be from the 50%. If we subtract the 2.5, then we will get 47.5. Okay, 47.5. So here is the 47.5. Okay, and this side is also 47.5. It means that within this range, it will be acceptable, and the rest of the part, so this part, it will be a rejection zone. Okay, so this will be our rejection zone. Okay, so 47.5, or we can say the 47.5 is equivalent to 0.475, 0.475. The 47.5% is equivalent to 0.475. Okay. So now what we have to do, so we have already identified the rejection zone. Okay, rejection zone. Now what we have to define the rejection area, and we have to utilize the G table for the critical point. Okay, for the critical. So for the G table, you can see it is a two-tailed test. So we have to now see two-tailed test. That is, we can say two-tailed G table. So here is our, for the two-tailed G table. Okay, so for our two-tailed G table, we can see that here. So in our case, it is 0.41. What's that? It's 0.475. So 0.4. Yes, this is our case. That is 0.475. Okay, sorry. So we need to find out the value here, that is 0.475, to find out the critical point. So here is 0.47. Sorry. So here is this. This is our 0.475, and we can see it is 1 point here. You can see 1.9, and it is 0.06. Okay, so it means that, so 1.9 plus of 0.06. So our critical point will be 1.96. 1.96. Okay, so we can see that. So in our case, after the alpha value 0.5, we subtract that value, that is 5%. So from our 50%, we have subtracted the 2.5%. So here the 50%, we have subtracted 2.5. So it is 47.5, which is equivalent to this value, that is 0.047. And now we have to find out this. That is, we can see that this percentage means in our table what will be our critical point. So the critical point you have to find out in our table, that is a total table here, the total table. And we can see for the total table, where is our, that is 0.475. So we have to find out this value 0.475. So to find out this value, we can see here, this is the point where we got the 0.475. So 0.475. Now in this case, we can see there is the G is 1.9, and here is the 0.06. So G 1.9 plus 0.06 is 1.96. So this is the G value of our table. So from the G table, we got the value 1.96. 1.96. So now from here, we can see that this is the point, actually the critical point. The G table value or G score, we got the G score value is 1.96. Okay, so G score is from the table, we got the G score is 1.96. 1.96. So that is our critical point. Okay, critical point. So we can say there is beyond that actually the rejection zone, and within that it will be acceptable zone. And in both of the side we have to check that one. So here is in positive side it is 1.96, and in negative side it will be at this point it will be negative 1.96. Okay, negative 1.96. So that is G score here is 1.96, and here is a negative 1.96. And we know how to calculate the G score from our last discussion. And now from this statistics, we need to find out the G statistics. Okay, G statistics. So here is the equation for the G statistics will be, here's the X bar, that is mean minus of mu 0 divided by, here is the sigma divided by square root of n, square root of n. So this is how we can find out the G statistics. Okay, G statistics. And in this case, we can see X bar mean. This mean is our sample mean. Okay, so we can see here is the sample mean. So sample mean, we have this, that is after taking sample of 30 patients, we observe the mean, that is 140. So here is the 140, and then this is the mu 0. Usually we call it the population mean. So population mean, we can see the population mean at this stage it is 100. So here is the 100. So that is X bar is 140 and mu 0 it is 100. Then divided by the sigma. So sigma is our population standard deviation. So population standard deviation is 15 here. So 15, and divided by, so divided by square root of n. So square root of n. So square root of n. N is how many samples we have. N samples. In this case, sample size is 30 patients. Sample size is 30 patients. So here is the 30. Here is the 30. So now if we do the math, then we will get 14.6. 14.6. So we can see that the 14.6, it will be, this will be, that is far from our critical point. There is 1.96. So this 14.6 actually far greater than 1.96. So what does it mean? It means that the 14.6, this is actually in rejection zone. Okay, in rejection zone, because within this part is our rejection zone. This part is our rejection zone. So the rejection, it falls in the rejection zone. It falls in the rejection zone. So what we can say, that the null hypothesis is rejected. Okay, null hypothesis is rejected. So that means we can see here there is the G statistics value. So this is our G statistics, or calculative G. So this is far greater than our that is a G score, or G from the table. Okay, G from the table, or critical value. So that's why we can reject the null hypothesis. We can reject the null hypothesis because you can see those are in rejection zone. Okay, the rejection zone. So that means this hypothesis is rejected. The null hypothesis is rejected. Null hypothesis is rejected. It means that usually we say that null hypothesis is rejected. Usually we don't say that the alternate hypothesis is accepted. So null hypothesis is rejected. It means that the average, the obese patients, the blood glucose levels of obese patients, that is the mean of is 100. So this idea, or this thought of common people, this is rejected. Okay, this is rejected. And here is the researcher's thought or hypothesis. If this one is rejected, then usually we call that, okay, maybe this one is accepted. Okay? Maybe this one is accepted. Alternate hypothesis is accepted. Okay, so this is the two-tailed test. Now we can maybe think about another test. So another test is also, that means we have to follow the same thing, like state the null hypothesis and state the alternate hypothesis. Then we have to set the significance level, and then find the rejection area, and then test statistics, and also whether we have to accept or reject the null hypothesis. So now here is another problem. The problem is, a principal at a certain school claims that the students in his school are above average intelligence. So it is mentioned that there is that the students in his school are above average intelligence. That means intelligence than the average people, or average students. Okay, and for that, and for that, a random sample of 30 students. So here is the 30 students. Okay, random sample of 30 students. IQ score have a mean score of 112. So a random sample of 30 students IQ score have a mean score of 112. So is there sufficient evidence to support the principal's claim? Okay, so that means from that school, we have taken just 30 students and tested their IQ, and we observed that the IQ score of the sample students, this is 112. So whether the claim of this, the principal's claim, or we can say principal's hypothesis, that the average IQ score of his students is higher than the average IQ score of other students. Okay, so whether this claim is true or not. So that's why it is mentioned that, is there sufficient evidence to support the principal's claim? So additional thing is given, like the mean population IQ is 100. So mean population IQ score is 100 with a standard deviation of 15. So it is given like 115. This is the for the general students IQ score and their standard deviation. So what we have to do at first, we need to formulate the problem, that is the H0, and then we have to state the alternate hypothesis, and then set the alpha level, and then we have to find out the values from the critical values from our G table, and then we have to find out the test statistics, and after that we will decide that is whether the null hypothesis is rejected or accepted. And for that, here we can see there is in this case also the mean population IQ is 100. So that means in our case the null hypothesis is mu equal 100. mu equal 100. This is our null hypothesis. And then the alternate hypothesis is this, that is, we can, based on the principal's claim, that is his student's IQ score is greater than the average. Okay, so greater than the average, you can see that means the mu, it will be greater than 100. So greater than 100. And we can see that from this alternate hypothesis, from this alternate hypothesis, we can see that is this is a one tail test, not the two tail test. We can see that just only greater, not the less. Okay, so this is the one tail test, and that is the greater side. And now what we have to do, we have to think about the significance level. Consider that the significance level at this stage is also alpha equals 0.05, that is 5%. Okay, so 5%. Then the next thing is we have to find out the values from G table, that is the G score. We have to find out the G score values, that is critical values from the table. And it is one tail test. Okay, one tail test. That means it we can say that here this is the 50%. Okay, here is the 50%, and here is the 50%. And now we can see that it is a one tail test, and we have the significance level like 0.05, that is 5%. So we will have like 100 minus of 5, that is 95%. So this is our 95%. This is our 95%, and the rest of this part, it will be 5%. Okay, so actually this part is the rejection zone. Okay, this part is the rejection zone. This part is our rejection zone at this in this case. Now we have to find out our G score. Okay, G score. And now we can see here it is so from the 95%, it means that it is 0.950. Okay, 950. So now we have to use the G table, but this time there is not the two-sided table, or we have to apply the one-tailed. Okay, so G table. So this is our G table for left and G table for right. And we can see this is for the left. Actually, we need to find out G table for the right, because our rejection area is on the right side. Okay, so we should not use this. We have to think about, yeah, this one. Okay, so we need to find out what? We need to find out the value is 0.950. Okay, then 95. Okay, so here is a 94595. Okay, that means 0.9495. Here is a 0.9505, 9515. So that means the value will be within this range. Within this range, 0.9495. There is a 0.9505. Okay, 9505. So that means within this range, we have to think about this one. And so here is the 1.6, and then this is 0.4, and here is the 0.5 and 0.5. But between these two, we have to find out a number for that. Okay, number for that. And we can see there is so here is the difference. Okay, the difference we can see first the difference between this 0.95 and 0.94. The difference here The difference is 0.9505 minus of 0.9495 equal. So the difference is actually 0.001. So it is 0.001. So 0.001. So here is the difference. And the difference in this case, it is 0.5 and here is 0.5. So 0.5 and 0.4. So the difference is in this case 0.01. So, okay, but what we need here, this is 0.95. In this case, we can see here it is 0.9495. Okay, 9495. Now, if we want to find out the difference here, like 0.95, and we have 0.9495. Okay, so again, you can maybe find out the difference. So it is 0.95 minus of 0.9495 equal. Actually, the difference is 0.0005. So here is 0.0005. Okay. So we can see that for this difference, for the difference of 0.001, for the difference of these values, the difference in x-axis, the difference in z values of in our y-axis, we can see y-axis that is 0.01. Then for the difference, we can see if for this difference, what will be the case? So on that case, that is we can say for difference 1, it will be 0.01 divided by 0.001. Okay, and for the difference, for this difference, because we can see that we want to get 0.95, but we have here 0.9495. So the difference here is 0.005. So for this difference, that is for 0.005, the difference will make in y-axis values. It will be here is 0.01 times 0.005 divided by 0.001. Okay, so that means we can see here, if we do the math, so it is 0.005 times 0.01 divided by 0.001 equal. It is 0.005. So that means 0.005. 0.005. Okay. So 0.005. So this value, it means that we have 1.6 plus 0.4, 0.4, then we will get it is 0.9495 plus of what? Plus of this value, plus of this value 0.005. It means that total value will be we have 1.6, 1.6, then we have 0.04, then 0.04, and then we have also for this difference, the difference is 0.0005. What is difference? The difference of y-axis g values will be 0.005. So that means you can say 0.005. So we have to add these three. So we have to add all. So it is 5 and then 4. Sorry. So we will get then 4 and then here it is 6 and 1 point. So 1.645. Okay, 1.645. So we will get similar to that. Okay, 1.645. So here is this. We can see that 1.645. So that means the critical value from the G table we will get 1.645. So 1.645. Now that means from the table we got the G score, and G score is our 1.645. Now we have to find out G statistics. Okay, G statistics. So here is a G statistics. Using this formula, we have to find out G statistics. And at first, the population mean. The population mean we can see from our the 30 students test. The population. Sorry, the sample mean is 112. So here the X bar is our sample mean. The sample mean is our 112. Okay, and then our population mean it is given, the population mean is 100. So here is the 100, here is the 100, and then uh, the sigma is given. So sigma is, in this case, it is 15. Okay, so sigma is 15. You can see here the population standard deviation is 15, and our student number of students 30. Okay, so number of students are square root of 30. Then we will get the value 4.56. Okay, 4.56. So 4.56 G, this is the G value, and we can say this is also the 4.5. It will fall in this region. Okay, it will fall in this region. That means it is greater than 1.645. So it is greater than 1.645. So 1.645 greater than, that means it will fall. The statistics actually fall on the rejection zone. So that means we have to reject the null hypothesis. We have to reject the null hypothesis. That means 4.56 is greater than actually our 1.645. 1.645. Okay, so it will be, this value is actually in rejection zone. So we have to reject the null hypothesis. So null hypothesis rejection means we can accept the alternate hypothesis. Usually we mention that we have to reject the null hypothesis. So the claim of the principle is somehow true. Okay. Okay, so we have already discussed about two hypothesis testing examples. This example, problem 1, and another one, this example in problem 2. Okay. So for a given problem, it is important to understand that for whether we have to apply, there is the one tail test and two tail test, okay? And in which side, if it is one tail test in left side or in right side. And we can see that in this case, the population mean and also the sample size, all those are numeric values, okay? All those are numeric values. So sometimes you will get numeric values to test your hypothesis, and sometimes you may not get your numeric values to test your hypothesis. So that means, yeah, based on that, you have to think about like which kind of test actually you have to perform. There are several tests in our hypothesis testing method. The popularly we use for the numeric values, popularly we use the T and G test. But when we have to apply T and when we have to apply G, uh, so we can see that this is the case usually when we use the T test, and for all other cases we will use the G test. So when it is suitable to apply the T test, here the sample size is small. The sample size is small and population variance is not known. So this is the ideal case for applying t-test. There is sample size is small and population variance is not known. So population variance is not given or not known. So on that case, we can apply the t-test. For all other cases, like if sample size is large and population variance is given, then this is the ideal case for applying the g-test. Population is large. And another case like the sample size is large, sample size is large. Here variance, this is the variance is known, but here it is called that this variance is not known. Even though not known, you have to apply g-test. Then sample size is small. This is similar like this one, that is t-test. So we can see these two are similar. So the sample size is small. Here it also sample size is small. But we can say variance is known, and here is the variance is not known. Variance is not known. That is population variance is not known. So population variance is not known. Then here is the known. So that means if the sample size is small, even though the sample size is small, if the population variance is given, then apply the g-test. Even sample size is small, sample size is small, population variance is known, then apply the g-test. Okay. So let's see, that is, what does the small mean? The sample size is small mean. So usually we can mention that the sample size less than or equal 30 is called the small sample. So that is sample size less than or equal 30, then usually we call those are just small samples. Small samples. Now we can see here, okay, we can see that there is the sample size in this case is 30. Sample size is 30. And the population mean, that the population, you can say the variance, standard deviation, that is variance. Population variance is given. So sample size is small, population is given. Apply g-test. Previous here. There is sample size 30 students. Okay, that means it is small, but population standard deviation is given. So apply the g-test. Okay, apply the g-test. Here is the sample size is 30, small, and the population here is there is standard deviation is given. So apply g-test. Okay, apply g-test. Okay, so now a little more about that. That is a t-test, or we can say a g-test. It can be like one sample t-test, or two sample t-test. What does it mean? One sample and two sample. So one sample t-test and two sample t-tests. It means that so you apply just you apply sampling technique one time, the single time, that is called one sample t-test. And if you apply sampling technique two times, then this is called two sample t-test. Okay. Uh, so here to compare sample mean with that the population mean. So that means we can see the t-test value will be the t. The same thing, like we can see this is our sample mean minus of this is our population mean divided by this is S. This S means the sample variance. Okay, sample actually standard deviation, uh, and then square root of n. So here we can see that x is the sample mean, x bar is the sample mean, s is the sample standard deviation, n is the sample size, and mu is the population. So if we have two sample t-test, then to compare the means of the two different samples, here is the mean of first sample and mean of the second sample, and then square root of there is here uh, the variance of first sample divided by n1. There is number of samples in our first sampling, and here the s2 square, that is the variance of second sample, and the number of elements in our second sample. Okay, so, so in this way we can find out the value of the t. So this is the t statistics. Okay, so find out the t statistics and then compare with our that is table of t. Then we will again think about whether we have to reject or accept the null hypothesis. Okay, so if the value of test statistics is greater than the table value, so if the value of the test statistics like t statistics, so this t statistics, that means from the data we can calculate that if this one is greater than the table value, or we can say t score, or we can say t critical value of t t score, then what we have to do, we have to reject the null hypothesis. Okay, we have to reject the null hypothesis. And in another case, if the value of test statistics is less than the table value, then just don't reject the null hypothesis. Okay, in reverse case, don't reject. Okay, so that means we can we have this equation, and based on our t-test results, tabular test values, we can reject or maybe accept the null hypothesis. And similarly, g-test can also be like one sample g-test and two sample g-test. So one sample g-test we have already discussed about that. Okay, so one sample g-test, and for the two sample g-test, in this case, the first sampling, mean of the first sampling, mean of the second sampling, and then variance, and there is the population. Uh, that is our first sample, and the variance of our second sample, the number of elements in first sample and number of elements in second sample. Okay, then the we will again get the g score, sorry, g statistics, and based on the g statistics we have to compare the values with the g score or g critical values, and then based on that we can either accept the hypothesis or maybe reject the hypothesis. So one thing sometimes we need to calculate, that is called the sample size determination. Okay, so that means from the population you want to take the sample, but how many that is students data you have to collect, or we can say how many samples you have to collect. So one of the there is method for collecting, there is how many samples. The standard number of sample size is this method. There is n, g square p1 minus p divided by e. So this is proposed by Wasana in this. Okay, this the paper is here given. Okay, so in this case, that is the p. This p is our p value. Okay, p value. So we will learn about the p value actually in our maybe next lecture. So usually we set some p value uh, like 0.5. So that means how much confident uh, we want to accept, how much confidence we want to accept. And then was selected rather than likely prevalence given the maximum possible requirements and specifying the margin of error. Okay, so margin of error we can specify the p. So here is the e, another is this error. So it is e is 0.05. It's kind of the alpha. Okay, kind of alpha value. Here is this e. And G here, it represents the value from the standard normal distribution corresponding to our 95% confidence level. That is our 1.96. Okay, so that is our G. This is our from the table. From the table, we will if we consider the 95%, because you can see here the p value is 0.5, so 95% confidence level. The G will be from our G table, and in this case maybe we will get just 1.96. Okay, 1.96. So for 95% confidence, and if we put those scores here, then we will get the n, the the population, the sample size here. The sample size you can see n is 385 participants. So we need that is 385 participants for the validation, for the statistical validity. Okay, so that is, sometimes we need to know the sample size, that is how many samples will be the correct. Okay, all right. So according to the Wasena et al, we can apply this formula for determining the sample size. Now I think we can continue our discussion here. Regarding the hypothesis testing. So far we have studied there is the hypothesis testing method, only T and G test. We have seen the two tests, but there are some other testing methods also. Okay, so we need to consider when to consider which there is method. We have to we have to learn a little bit more about that. So for the hypothesis testing, that is, we can say hypothesis testing, usually, as I already mentioned, the null hypothesis and alternate hypothesis, we have to form these two types of hypotheses. One is null and another is alternate hypothesis. The null is the common goal or common belief, or you can say that is the kind of the that is common established fact. That is our null hypothesis. So usually we test the null hypothesis always. Okay, so always we test the null hypothesis, and that's why we can reject the null hypothesis or we can accept the null hypothesis. So see here is the hypothesis testing. Usually what we have to do, we have to apply some statistical testing method. This testing method broadly we divide in two types. One called is parametric test, another one is called non-parametric test. So there are several parametric tests and non-parametric tests, and that is the we have done already G and T test, and those are actually parametric tests. And some non-parametric tests we have like this, the chi-square test, the U test and H test. So those are actually our non-parametric test. So non-parametric test. Then what is parametric and what is non-parametric? The parametric tests are applied under the circumstance where the population is normally distributed or assumed to be normally distributed. As I already mentioned that there is all the parametric tests. Usually we assume that the data we have collected from the population as a sample, so it will follow some normal distribution. So even though some will follow not the normal distribution, but we need to assume that those are normally distributed. So at least the assumption. Then in parametric test, we have to have some form of the mean standard deviation. We have to use those things. Like we have given the two examples, and on those examples, that is for defining the hypothesis, like H0 and H1. We applied the mean value, like the mean is equal 100. Okay, mean greater than or not equal 100, like this. Okay, so that means the standard deviation also we have used. That is sample standard deviation, population standard deviation, those things. Okay, so those are the parametric. Those are the parameters here. That is called the parametric, because mean standard deviation, those things usually we use. And parametric test examples are t-test, z-test, f-test, and ANOVA, and also Pearson correlations kind of parametric test. So when we have to apply parametric test, uh, these are applied, these tests are applied where the data is quantitative. So that means the quantitative, so from the quantitative data, we can determine the mean. Okay. So when the data is not quantitative, we cannot apply the parametric test. Okay. So these are applied where a scale of measurement is either interval or ratio scale. So that means a scale of measurement in either interval or maybe you can say ratio scale. So that means when we collect the data, so the data usually on the form of interval, okay, or maybe in the form of ratio. So what does interval means? Interval means that uh, some values will be there, but we have to form the beam with uh, with same size, okay, same size. Like maybe the age is given. So age we can say maybe within the range of 0 to 100, okay, 0 to 100. But the interval means we can divide this into a distribution, like uh, the scale interval is the first scale is 0 to maybe 10, and then 11 to 20, uh, and then 20 to maybe 20, 21 to 30. So we can see that there is the even space, okay, even space, evenly distributed. So here is usually 10 elements, here is 10 elements, and 10 elements. That means these values, we can say that is the divided in some interval or sometimes in ratio scale, okay, the ratio scale measurements. And how about the non-parametric test? So non-parametric tests are applied under the circumstance where the population is not normally distributed. So that means if we can find out that our data is actually not normally distributed, some kind of skewed distribution I have, maybe left skewness or it has the right skewness, okay, or we can say it is the kind of the uh, kind of the zigzag pattern, okay, so that those are not normally distributed. And where the parametric test cannot be applied, so that means when we cannot apply the parametric test, because we can see that maybe the mean is not given, the standard deviation is not given. So on that case we have to apply the non-parametric test. The tests are also like the distribution free test, okay, so distribution free test, that's why it is not usually we assume that normal distribution, but we can say there is some form of skewed distribution are there. So we may not name those distributions as like maybe gamma distribution or something, okay. So that's why it is called also distribution free test. And parameters like mean, standard deviation are not used, okay, so, not used. Some of the non-parametric tests, one of the popularly used test is that the chi-square test, okay. And U test usually Mann-Whitney test, we call it U test. And then Kruskal-Wills test usually we call the ACE test, okay. And Spearman's rank correlation test is also one kind of non-parametric test. Okay? So these are non-parametric tests. So we will discuss specifically the chi-square test as a non-parametric test in this course. So these are applied when data is qualitative. Okay, so here is this name. That is not the quantitative, it is qualitative. So qualitative, like very good, excellent, outstanding. So those are qualitative. Uh, and these are applied where a scale of measurement is either ordinal, a scale of measurement is either ordinal or nominal scale. Okay? So here the ordinal scale means the first, second, third, those are the ordinal. Okay? Ordinal. A nominal scale means there is okay the different classes like maybe uh, the class of vehicles like car, uh, the, 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 the tractors. So those are usually we call the nominal scales. Okay? Nominal scales. So for our non-parametric test, the apply that is you can say it will be some form of ordinal values or you can say nominal values or you can say classes will be there. Okay, now for the hypothesis testing, I think we have already discussed this thing. Usually, hypothesis is our educated guess, and then after testing, we can say that we can predict the relationship between one or more variables. For the null hypothesis and for the alternate hypothesis, the differences are actually stated here. The null hypothesis is a statement which state that there is no relationship between variables. Usually, no relationship. Okay, so the common fact is no relationship. Usually, we can say. Or in alternate hypothesis, a statement states that there is a relationship between variables. There is our uh, uh, the dependent and independent variables. Okay, for example, here increase the number of cancer patients is not due to the increase of population level. So this is a null hypothesis. Usually, we can say that there is the increase of cancer patients, and those are not due to the increase of population. Okay? There is common belief. But when a researcher will claim that okay, that is cancer patients are increased due to the increase in population level. So this is a claim from one of the researchers. So that is our alternate hypothesis. Usually we denote by HO and it is denoted by H1 or HA. And so it is an exact opposite of what investigator predicts or expects. So that is, and we can say the alternate hypothesis, it is exactly what the investigator predicts or expects. Okay? So this is the investigator will test this one. And this is common belief, or you can say, yeah, just a common. So it is a null hypothesis which being tested and statistical tests are performed on null hypothesis. Okay? Just only null hypothesis. And statistical tests are not performed on the alternate hypothesis. So that's why usually we call null hypothesis is either be rejected or not rejected. Okay, so that means null hypothesis. Sometimes you can say we will reject the null hypothesis, and sometimes you can say that it is not rejected, or you can say the null hypothesis is accepted. So I think we can stop uh, at this slide, and in our next class we will discuss about the confidence level, p-values, and also there is the chi-square test. Those things we will discuss in our next class. How to define the confidence level and chi-square test. So chi-square test is one of the non-parametric tests we will discuss in our next class. Thanks all of you for joining this
Sir,
session.
sir, do we
Yes,
have
please.
this theory part in our exam?
Theory part means
Sir, the differences and explanations.
uh, sometimes maybe I will ask the question of 1 or 2 marks about the theory part. Okay. So actually the theory is for solving the problems also. A problem will be given and then you have to understand that there is what type of test actually you need to perform. Okay, so without knowing the theory, I think it's difficult to select the test also. So that's why uh, I think we should study the theory also.
Yes, sir, understandable. Also, sir, how many parts of the statistics we have for our final exam? Because in your drive, I have seen that you have 4 parts.
Yeah, that's why maybe I will try to complete all the four, yeah, up to the ANOVA testing. Is it
Sir,
fine?
that will be our syllabus up to.
Uh, I think I don't know how many classes we have. So we can extend the syllabus and we can reduce the syllabus. That's why uh, it will depend how many classes we have and how there is
Sir,
how
maybe
much
we will
topics we
get
want to cover.
4 classes before our finals.
Okay. So in one of that class, maybe you have to present your project. Then
Yes,
we
sir,
will
the
have,
very last
yeah,
class.
yeah. Then we will have just 3 classes. Okay? Next 3 classes.
So the project Excel sheet is not editable.
Project
Excel sheet is not editable, sir.
not editable.
It's only
Uh,
view only, sir.